In binder jet additive manufacturing, we're depositing a liquid binder onto a powder bed to form part geometry. After printing, the entire powder bed is removed from the printer so that it can be dried in a curing oven and a new print can be started. In the crosslink oven, a series of cross-linking reactions happen to the binder, giving the parts the strength they need to continue into sintering. After drying, the parts are strong enough to handle during the depowdering process. The depowdering process removes the parts from the powder bed and recovers all of the loose, unused powder that was not printed on. This powder gets reused in future builds. In metal binder jet printing, depowdered parts are then prepared for sintering. Sintering is the final step in metal binder jetting and is critical for producing a highly dense, precision part. During sintering, the green parts are heated in a furnace to temperatures approaching the melting point of their metal alloy. The metal particles fuse together to form a solid mass. During this process, green parts will shrink up to 20% depending on their material. Our live sinter software simulates this shrinkage and any associated distortion, creating an offset of your design for printing so that the final part meets tight tolerances, consistently within 1% of the design dimensions. Parts produced by Desktop Metal's metal binder jetting process can be machined, polished, plated, or otherwise post-processed exactly the same as metal parts produced by other traditional manufacturing processes, like metal injection molding. Metal binder jetting and metal injection molding use the same powdered metal, the same furnaces, and are held to the same industry standards. The Powdered Metal Industry Federation published Standard 35, which defines the properties that can be achieved by metal injection molding. These same properties are achieved by Desktop Metal's metal binder jetting process. And this is why metal binder jetting unlocks the true potential of powdered metallurgy.